Theorem 6.4 and Theorem 6.5. Theorem 6.4 says that if a transversal intersects two parallel lines, then each pair of interior angles on the same side of the transversal is supplementary. So what is given here? It is given that there is a transversal and there are two parallel lines. So in this figure, we can say that the transversal PS intersects parallel lines AB and CD. So there AB and CD are parallel lines and PS intersects them at point Q and R. So the figure is understood. Now, we need to prove that is angle AQR, that means this angle AQR, and angle QRC, that means this angle, and as you can see they are interior angles on the same side of transversal, the left hand side of the transversal. Is their addition 180 degree? That is what we need to prove. Okay, so let's see the proof. We know that since line AB and line PS intersect at Q, so you can see this line PS and line AB intersect at Q. Angle PQA, so angle PQA, this angle, plus angle AQR, that means this angle. So let's call it angle 1 and angle 3. So angle 1 and angle 3 make 180 degree, right? Because they are linear pair. Is PQA, so that means this angle PQA, angle 1, also equal to QRC? So let's look at QRC and we will call it angle 5. I'm going to number them all. So angle 1, PQA, is it also equal to angle 5? Yes, because they both are corresponding angles. And corresponding angles axiom say that if two lines are parallel and there is a transversal cutting it, then the corresponding angles are equal, and therefore PQA is equal to QRC. Now look at this first equation that we have got. PQA plus AQR is 180 degree. Now, can I put QRC in place of PQA because they both are equal? Okay, so can I shift this here? Yes, we can. So substituting angle QRC in place of PQA, we can say that here now in place of PQA, I'm putting QRC. So QRC plus AQR is equal to 180. QRC plus AQR is equal to 180 degree, and that's what we need to prove. QRC, that is angle 5, and AQR, that is angle 3. And so we have proved that 3 plus 5 is equal to 180 degree. So that's proved. The next theorem says, if a transversal intersects two lines, so a transversal is intersecting two lines, it is not said that the two lines are parallel, but it is said that such that a pair of interior angles on the same side of transversal is supplementary. That means addition of one pair. Let us number them again. 1, 2, 3, 4, 5, 6, 7, 8. So let us say that 3 plus 5 is 180. It is given to us that angle 3 plus angle 5 makes 180. We need to prove that the two lines are parallel. So we are proving the opposite of theorem 6.4. Okay. In this figure, the transversal PS intersects AB and CD at Q and R respectively, such that angle AQR, that is angle 3, and angle QRC, that is angle 5, is AQR plus QRC is equal to 180 degrees. So this is given to us in the question. But what we need to prove is AB and CD are parallel. if their addition is 180 degree, then the lines are parallel. That's what we need to prove. So how do we prove this? We will begin with what is given to us, that angle AQR plus angle QRC is equal to 180 degree. That is given. So angle 3 plus angle 5 is equal to 180 degree. But we have to prove that AB is parallel to CD. So if I can prove that angle QRC, that means angle 5, is equal to angle 1, if I can prove that these two are equal, then I can say that using the converse of corresponding angles axiom, I can say that AB is parallel to CD. So I am trying to prove that 3 plus 5 is 180 degree, but then if is 5 equal to 1, let's prove that 5 is equal to 1. So for that, I'm going to use these two angles, addition of these two angles, because their addition is also 180 degree because they are linear pairs. So I'm going to use that. Since we know there is a transversal and two lines intersecting, the transversal is intersecting two lines, therefore there is going to be a linear pair here. So let's use that information. So we know that since AB and line PS, so AB here and PS intersect at Q, angle PQA, so PQA angle 1 plus angle AQR, that is angle 3, their addition is also 180 degree, and we will take it as result 2. So result 1 is AQR plus QRC is 180 degree, and result 2 is PQA plus AQR is 180 degree. So because both of them are equal to 180 degree, we know that they both are equal. So we are going to use that things that are equal to the same thing are equal to one another. So we are going to write as 1 is equal to 2. We can write that angle AQR plus QRC is equal to angle PQA plus AQR. So that's how I get this. Now, as you can see on both the sides, I have AQR and AQR that will cancel out and become 0. Because if you imagine this AQR will go there and become negative, and so one positive and one negative makes 0. So what do I get? QRC is equal to PQA. So QRC angle 5 is equal to PQA angle 1. But angle 1 and 5 are corresponding angles. So we are going to write, but angle QRC and angle PQA are corresponding angles, right? As you can see, PQA and QRC, this angle, they both are corresponding angles, so they both are equal. And therefore, axiom 6.4 states that if a transversal intersects two lines such that a pair of corresponding angles is equal, if a pair is equal, then the two lines are parallel. And because a pair of corresponding angles here are also equal, we can say that AB is parallel to CD. Hence proved.